More fun and games with inverses. They give us x squared minus 4, and they want a graph first. Well, this is a parabola, and the only thing that's different about it from the standard parabola is it's translated 4 units down. Notice that each of these squares is 2 units, so yeah, this is correct for negative 4. And let's see if we go 1 over 1 up, 1 over 3 up. I don't want to plot a lot of points, but just enough to get the width generally correct. Okay, so in blue, there's our original f of x. Its domain, because it extends forever to the left and right, would be x can be any real number. And its range, since it starts at minus 4 and rises from there, would be y can be any real number as long as y is greater than or equal to negative 4. Then they ask for the inverse. So if we start with y equals x squared minus 4, and we swap the positions of x and y, add 4 to each side, and square root, we get y is plus or minus the square root of x plus 4. This inverse is a radical, meaning it should start at the axis and hook off to the right. And because of the plus 4, it's translated 4 units left. So its vertex is here at negative 4, 0. The positive version will hook like so, and the negative version will hook more like this. And yes, those look like inverses. They look like reflections across the usual line. Right about there, y equals x. Graph the inverse on the grid, done, and state its domain and range. For the red curve, the domain starts at negative 4 and then extends forever to the right. So x can be any real number, and as long as x is greater than or equal to negative 4. And y, because this part extends upwards forever and the bottom arc extends downwards forever, the range is simply y can be any real number. Notice again how the domain and range of the original and the domain and range of the inverse are identical, except that x and y have traded places. So when you swap x and y in this function, they also swap positions in the domain and range. That can save you a lot of work sometimes. For some functions, finding the range can be really difficult, but finding the domain of its inverse is really not bad at all, so that's a good tactic to have in your toolkit. Is the inverse a function? What do you think? If we did a vertical line test, this thing fails like crazy. There's hardly anywhere that you could draw a vertical line through this thing and only hit it once, so therefore, no, it is not a function. Not even close. Could we make it a function? Well, remember back here, we had this plus or minus. If you needed this thing to be a function and you could live with only working with half of the graph, you could do something like y equals just the positive root of x plus 4. Or there's technically no reason you couldn't work with the negative instead. Either one of these pieces is a function by itself, either the top half or the bottom half. It's just when you have both of them at once that it stops being a function. It's no longer one-to-one.